All right, let's try using the law of sines to solve triangles. Remember, the law of sines is that when we're given triangle ABC, side A is related to the sine of angle A in the same way that B is related to the sine of B in the same way that C is related to the sine of C. I also want to remind you of our congruency theorems, that if we're given side, 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 angle, 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 that's what all of these, of course, represent. Now, this is all of the permutations of sides and angles, right? And if we're given side, 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 then there is only one unique triangle that has that measurement. But when it comes to angle, 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 remember that's when we could have a large equilateral triangle or a small equilateral triangle. So with angle, 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 things are similar, but they are not congruent. So that is not a congruency theorem. Then when we're given one side, notice that we could have the side come first, in the middle, or at the end. Of course, side, angle, angle, and angle, side, side are the same thing, so I'll forget about that one. And when it comes to angles, that angle can come in the beginning, in the middle, or at the end. And in the same way, having it at the end is the same as having it in the front, so we don't need to list it twice. We also have to remember that with angle, side, side, we don't necessarily have one unique triangle. Way to remember that, of course, is you shouldn't be swearing in math class anyway, so we'll cross that one off too. So we really only have 4 congruency theorems: side, 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 angle, 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 side, angle, and side, angle, side. So what if we're given that a triangle has angle A of 30 degrees, angle B of 70 degrees, and side C of 20 degrees? Well, when we take a closer look at what we're given, first of all, side C has to be this long. On the ends of side C are the 2 angles, A and B. So if we have angle A over here and angle B over here, then there's only going to be one place where the vertex C could be, and that would be right here. So this is the only triangle that we could be talking about. Now, when we want to solve a triangle, that means we're going to need to find all the angle measures and all of the side lengths. So I'll usually set up this problem in this way. First, I'll organize all my answers: angle A, angle B, and angle C. And with each of them, of course, I'll list out the ones that I know. I know that angle A is 30 degrees. I also know angle B is 70 degrees. Well, that makes 100 degrees, so angle C must be the 80 degrees that's left. Next, I'll get all my side lengths ready: A, B, and C, listing the ones that I already know, like that side C is 20 degrees. So it really looks like I only need to find 2 side lengths in this problem. And that's where the law of sines come in. Remember, the law of sines says A is related to the sine of A, which is 30 degrees, in the same way that B is related to the sine of B, which is 70 degrees, and the same way that C is related to the sine of C. So 20 is related to the sine of 80 degrees. So to solve this, I'm just going to take 2 of these fractions at a time. I'm going to take the one that's already filled in, of course, that 20 that's related to the sine of 80 degrees. And then I'll do A first. Now obviously A is my only variable in this whole proportion. Everything else has a numerical value. For instance, sine of A is 0.984. But I wouldn't recommend turning that into a decimal right now. To be more accurate, wait as long as you can. We know that the sine of 80 is going to be a number, and we know that the sine of 30 is going to be a number. So really, I have A divided by a number. To get rid of that number, I'm going to multiply by the sine of 30. And whatever I do to one side, I'm going to have to do to the other. These ones will cancel. Just leave us with A. But then on the other side, I have 20 times the sine of 30 degrees over the sine of 80 degrees. Now, you probably recognize that the sine of 30 degrees is a half, so 20 times a half would be 10. over the sine of 80. Then go over to your calculator. Make sure that you're in degree mode and do 10 divided by the sine of 80. If you type it in right, you should get 10.154. When you write your answer, I want you to go to 3 decimal places. The more decimal places we have, the more accurate we're going to be. Going to 3 is sufficiently accurate. Now we're almost done. We still have to find that third side. We can't use Pythagorean theorem to do that because we don't have a right triangle. So we have to use the law of sines. And now I'll just use the same fraction from C. 20 is related to the sine of 80 in the same way that B is related to the sine of 70. And this one's going to work in exactly the same way. I want to get B alone, so I'm going to multiply by the denominator, sine of 70, on both sides. So we'll have sine of 70 here. The sine of 70s will cancel. So B is going to be equal to 20 times the sine of 70 degrees over the sine of 80 degrees. Be careful when you type this one in. When you have multiple trig functions inside of a fraction, you have to make sure you close your parentheses correctly. But if you type it all in right, you should get a value of 19.083. It's actually 0.837. I get this question a lot. Do I have to round? Do I have to call that 0.084? In my class and a lot of places, either way is correct. Whether you round that number according to the rules of rounding, or if you truncate it, meaning you just cut that thing off and disregard the rest of them, either way is correct. We're going out 3 decimal places. That's a lot of accuracy. And if you're accurate to 3 decimal places, we're going to call it good. Now, before you leave this problem, you want to check on one thing to see if your answers make sense. How you're going to know if they make sense is the largest angle is paired with the largest side, and the smallest angle is paired with the smallest side. If those things happen, you're probably right. All right, here we're given 2 angles and a side, but that side that we're given is not the side that's in between the 2 angles. Let's take a look. We have the angle A is 22 degrees, and angle B is 49 degrees. Side B is 4.7. Since it's side B, it has to be on the opposite side from angle B, which means that it has to lie on this side of angle A. Now when we get to angle B has to be 49 degrees, but it doesn't say how long those sides of those angles are. So it just has to be in here. It has to match up with the base of our triangle. Oops. And it has to allow side B to be 4.7 units long. So this is what our triangle can look like, and it's the only triangle that we can get. So I'm going to go ahead and shorten up that one side so we have an accurate-ish looking triangle. Now let's get ready to do the problem. List out your angles: angle A, angle B, and angle C. We know that angle A is 22 degrees and angle B is 49 degrees. Together that makes what, 71? So if we start with the 180 degrees that are in a triangle, subtract out the 71 that we've already used, that leaves us with 109 degrees. That's what angle C has to be. Now for the sides, we have side A, side B we know is 4.7, and we don't know side C. So these are the 2 sides that we need to find. One thing I like to do when I'm using the law of sines is to recognize where I have a pair. And by a pair, I mean an angle and its side. Since I have angle B and side B, that's going to be my first fraction, 4.7 over the sine of 49 degrees. Then if I want to find side A, I'll set up my fraction there, A over the sine of 22 degrees. And just like before, we want to get A alone, so I'm going to multiply both sides by the sine of 22 degrees. On the right side, those two will cancel. And A is going to be 4.7 times the sine of 22 degrees over the sine of 49 degrees. If you grab a calculator, type everything in right, you should end up with 2.332 as your side length. And let's do the same thing for C. We'll start with our fraction that we have the pair for, 4.7 over the sine of 49 degrees is equal to C over the sine of C, the sine of 109 degrees. To solve this, we're going to multiply both sides by that sine of 109. Those ones will cancel. So C is going to equal 4.7 times the sine of 109 over the sine of 49 degrees. If you calculate that all correctly, you should end up with 5.888. Before you leave the problem, check and make sure that all of our answers look good. That meaning that our largest angle is paired with our largest side, and our smallest angle is paired with our smallest side. Once we have that, we can be pretty confident. Here, we're given two sides and an angle, which is just fine to do. However, when we take a closer look at what's going on, I have angle B, and I know that side A has to be 10 units long. So, right here. The thing about side B is that it has to be 7 units long. And that's all we know. We don't know anything else about it. We don't know where it is. One thing that might be helpful is looking at side C. Now, the thing with side C is we don't know how long it is. I do know that it has to be this side of the angle. So, side B has to come from the other vertex and reach the other side. So here is what our triangle could look like. But like I said, there's nothing that says that B has to be right there. I mean, B could be a vertical side and hanging down. But if it was vertical, then you notice that there's this little extra down here that's hanging beyond side C. So that means that our side couldn't be in that position. However, we could let that thing swing over to this side, and it would land right on side C. And so, let me put this back in here. When we have that side B, it's allowed to kind of swing freely because we don't know what angle C is. Right? So that side B could be anywhere down here. However, it has to land right on side C, so all this stuff in between can't happen. However, we do have two possibilities of where it could be. We could have it swing to the outside of that vertical or swing to the inside. So let's start with this triangle. When we set up our answers, we're looking for angle A, angle B, and angle C. We know that angle B is 40 degrees. It's the only angle that we know. As far as side lengths are concerned, we have A, B, and C. I know that side A is 10, side B is 7, and I don't know side C. Luckily, I do have this pair, so we can use law of sines. I'm going to start it off by saying 7 over the sine of 40 degrees, so side B over the sine of angle B. And I don't know anything about angle C or side C, so let's work on A, and we'll have 10 over the sine of A. Normally, we try and get the variable alone right away. Now that we're dealing with a proportion, we're going to want to cross multiply first. So we'll end up with 7 times the sine of A is equal to 10 times the sine of 40 degrees. Then we have to divide both sides by 7 to get those to cancel. Now we're at the sine of A is equal to this ugly little fraction here. Notice that I'm not typing it into my calculator yet. To get a alone, we're going to have to use the inverse sign. So it's going to be the sine inverse of this ugly fraction. Now, you can take this in pieces using the feature on your calculator that just takes the last answer and do 10 times the sine of 40 degrees, enter, divided by 7, enter, and then do inverse sine of that answer. And if you calculate it all correctly, you should get that angle A is 66.674 degrees. Next, finding that third angle isn't going to be too difficult because the triangle's got 180 degrees in it. We've already used 106.674, and so that'll leave us with 73.326 degrees. So we'll use that and the law of sines to find that last side. So again, start with our 7 over the sine of 40. And for side C, we're going to use the sine of that 73.326 degrees. This one, because we're looking for that side, is going to be a lot easier to calculate because we just multiply by the sine on both sides, and we'll end up with 7 times the sine of that 73.326 degrees divided by sine of 40. And when you calculate that all out, you should end up with 10.432. And now this triangle is solved. However, remember, we've got to find both solutions. The second solution is going to happen when we take side B and swing it inside that triangle that we just found, creating this triangle right here. So let's get ready to do the problem. We know that angle B is 40 degrees. We know that side A is 10. Side B is 7. Now we can use that information that we got from solving the triangle the first time to transition over to this second solution. Let me show you how. For instance, in that last solution, we found out that angle A here is 66.674 degrees. But if we take a look at this triangle, where we have both side B's in there, both of those sides have the same length, which means their corresponding angles have to have the same measurement, which means this is also a 66.674 degree angle. Well, we can just scoot over a little bit more, and now we can calculate this angle. If we moved angle A from where it was over to this spot, it's got to be 180 degrees minus the 66.674. And that gives us the obtuse angle, 113.326. Awesome. So now I know that angle A is the 113.326 degrees. I also already have a pair. I like using this angle B and side B. When I move on to C, we can calculate that one real quick because I have 2 of the 3 angles. So we're going to start with our 180 degrees. We've already used up the 113 and the 40, so that's 153.326, which leaves us with 26.674. And the only thing we have left to do now is find our last side. So again, we are going to have to use law of sines. 7 over the sine of 40 is equal to C over the sine of our 26.674. Multiply both sides by that sine, so 7 times the sine of 26.674 over the sine of 40. And if you calculate that all out correctly, you should end up with 4.888. And real quick, it looks like our largest angle is paired with our largest side, and our smallest angle is paired with our smallest side here and here. So we should be good. Now don't think that just because you're given angle side side, there has to be two solutions. That's not necessarily the case. Here we're given angle side side as well. So if I start with angle B, side B is going to be on the opposite side as that. Side A has to be 10, so I'm going to set that on this side of our angle. And then side B would have to connect there. I hope it's obvious to you that right now there's no way that we can get this triangle to work. B just isn't long enough. And that's usually the case, that if we can see the picture like this, it's obvious, we've got no other work to do, and we can just say no solution and finish it all up. But I've been doing this for a long time, and I know that if I just give you side A, side B, and angle B, you don't draw it out. Most of the time what happens is you jump right into the problem. Angle A, angle B, angle C. I know angle B is 72 degrees. I know side A is 10. Side B is 4. Side C, we don't know. So I recognize that we have a pair, and we're going to go right into law of sines. So you say 4 over the sine of 72 degrees is equal to 10 over the sine of angle A. Okay. Everything looks just fine. There's nothing that I have written down right now that makes me suspicious that there is no solution. So we just start solving. And we're going to cross multiply first. Okay, so we'll have 4 times the sine of A is equal to 10 times the sine of 72. Divide both sides by that 4. And then get A alone by using the inverse sine. You go head over to your calculator, type it all in, and you get a big fat error. Now, the reason for that is because of what happens inside of that set of parentheses. So inside of here, when we calculate 10 sine of 72 over 4, what you get is 2.377. Okay. So you're trying to take the inverse sine of 2.377. In other words, you're trying to find an angle whose sine is 2, all right, bigger than 2, but sine only has a value between -1 and +1, and that's why you're going to get a big error. When you get that error, then you can say no solution. All right? But it won't be until you get the error that you recognize that something is wrong.